Okay, everybody, welcome back to session 2. Justice, I'm going to let you go for it.
I share my screen and then we get started. Hello and welcome back to the second session, Motion Design with Copernicus. And I just want to bring this window over. Now it's done. And today we will focus on design. So we will learn about image composition, about camera. We will set up our own shot, our own camera angle in Karma and learn about lighting. We will work on this shot and we will also learn about how we can use Copernicus in creative ways in Solaris to do distortion, for example. So I would say, let's get started with image composition. Image composition is, of course, everybody knows it, it's crucial. And the first advice I want to give you is take time for design. It even rhymes. So it's really important to take time to find the best way to get the best design. And the first chapter, I think, is the most important in here. So I want to teach you that you have to see shapes instead of objects. So for example, it's important here in this image to don't see the grassland, but to see this X shape or this main green area. Why is it important? Because image composition is seeing main shapes, and this is the main important thing, to see the main shapes for image composition. So it doesn't matter to have all the details, but only the main shapes matter. And if you nail them, if you order them, if you give them an appealing order, then your image composition looks good. But that's why you have at first have to see the main shapes. And it's much easier to see if you look at the image from distance or if you zoom out a lot and then you get rid of all the details. It's also a technique from painters or from photographers to squint your eyes. You can also try it. Squinting your eyes by, let's say, 80%, and that way you additionally get rid of all the details and you really want to see the main shapes only, because that way you can see how the composition looks like, and otherwise you are distracted by details. We can also look at the image in black and white, because then we are not distracted by color. And let's look at some more examples. For example, this image in the main shapes would look this way. So having it small, again, it's much easier now to see the main shapes. And here again, only the main light in the middle of the car is the one important thing for image composition, like for the main shape, because this is what matters, what makes image composition, to see only the main shapes, because you have to nail them. And we want to arrange them in an appealing order. And what order is appealing? We will look into some ways to order and to organize your main shapes. So the first one is, if you want to have a static image, a static appeal, then you can have a horizontal line or horizontal shapes. So they give a dividing character, they also look graphical, and they also, in repetition, are very appealing to the eye. In general, a repetition is appealing. And the next way, it's quite similar. Next way we could use is vertical lines. It's quite similar, that they have a dividing character and a static appeal. We can also mix them with horizontal and vertical lines. And now we have a more static appeal, but if we want to have a more dynamic and especially holistic appeal, we can arrange our shapes in a circular way. So in this case, for example, we have a circular shape and it's often centered exactly in the middle. We can also check out this work, which has a circular image and a circular shape, and circular shapes are very appealing to the eye. So use them in your composition, in your main shapes. Then we have leading lines, like here, these leading lines. They drag the viewer into the image, and that's why it's good to use them in your image composition. They are very dynamic. Now we are more on the dynamic side. leading lines are dynamic. You can also see this here in the work by Dali. There's a leading line on the bottom left, and this is a way to implement them to have a dynamic appeal. Same as S-curves, like this one. This S-curve is also very, or in general, S-curves in your main shapes are very dynamic, and they appear aesthetic to the eye. They give a flow, so I would recommend to use them. For example, Man vs. Machine, in this case, used them as well. So they are really very appealing, same as C shapes, like here in this work by Florian Jury. So C shapes are similar. Using C and S shapes are dynamic as well and appealing. So we have another way. We could arrange our main shapes, which we now see, these main shapes. So one other way is we can use diagonals. So in here, for example, there are diagonals and they convey dynamic touch as well. We have, for example, descending or ascending diagonals. So now we got over the different examples how you can make your main shapes more appealing to the eye and how you could arrange them and really implement like the S-curve, C-curve, circular shapes, and so on, because it will help your image composition. And now we want to get into some rules in image composition. So the first one I want to talk about is the golden ratio. You can see it on the left. On the right, there's a simplification, the rule of thirds. I personally like the golden ratio a bit more because it's more accurate, I think. And we can simply take an image and overlay our, in this case, golden ratio, in this case, rule of thirds. And we have to position the main objects like the horizon or this tree on these crossing sections. So this is a way to also focus on these objects and to have them in appealing order. So the next, I want to show you something here. There's an HDA which implements these golden ratios and similar ways to do image composition to your camera. You can overlay it in the camera with this HDA. It's sadly not able to use this in Solaris, but in these SOP render contexts or in SOP renders, you can attach them to the SOP cameras and then they work. So I think this is quite useful. And we want to get into other rules, like symmetry, for example. Implement symmetry in your work and you have an more appealing image, because symmetry is appealing. It doesn't always have to be symmetry. It could also be asymmetry, but in general, symmetry, like here, is very appealing also in combination with repetition. And I would highly recommend you to use symmetry more often, because it's very easy to do, to improve your image composition that way. Frames, I think, are used far too little in 3D, but they're very powerful in image composition as well. So like here, for example, we have a frame with these clouds. They frame this mountain, and having this frame at the edges, for example, helps a lot because it gives an order and organizes your image composition. And I just made a quick sketch in 3D. In 3D, it could look like this, for example. Here, I have a frame at the edges of the image, and this is like, it helps your image composition because it focuses on the main object and it organizes the image composition. Another really important rule is to select a main focus. Like here, it could be an object, but it doesn't have to be an object. Like in this image, it's an abstract work, and also here we have this center area as a main focus, and you can simply do this by brightest area. The brightest area is where the eye looks at first, and then it goes to the more darker areas. So it really helps to lead the eye to select a main focus in your images and to use color, lighting, positioning, like in the center maybe, to use the main focus and to apply it. The next rule is we want to also keep in mind that less is more. You can see it in this work quite easily. Focus on the main thing of your image only. Here it's even more impressive, I think. There are great images by Sandra Bartocha. It's one of my favorite photographers. And less is more. You can see it here. Now we got through the rules, and I want to go to the next topic in image composition, which is perspective. In perspective, I want to begin with camera height. We have, like here, a high angle view versus a low angle view. And it's very helpful to have a high angle or low angle view compared to a normal height, because our eyes typically see a normal height, and then it's boring if you have the images also in normal height. It's more interesting for the eye if they see something which they see less often. So having a low angle or high angle view helps, especially, for example, if you have product shots and the product is like, you look at the product from below with a low angle view, then you can also look up to the product. That could also help. And the next thing I want to talk about in perspective is you want to get close. In photography, you say, if your image doesn't look good, then you have to get close. And it really helps, especially, I think, with wide angle lenses, for example. Flying through a simulation can help a lot, whereas looking into the simulation from outside, it's more boring. So get close, and that really helps. So the last thing I want to talk about in perspective chapter is the foreground, midground, and background. Adding foregrounds, backgrounds to your image gives depth and also makes the images more interesting, like you can see here. So now we got through the main rules and perspective, and I want to show you 3 things I always keep in mind when I do image composition. So the first thing I always keep in mind is I want to give objects an order. I want to organize the objects that way that they don't overlap. I want to organize them like on the right. I think I'd like to begin to don't let them overlap and organizing them in that way. And then, of course, in this case, we have on the left, it's more dynamic. If we have them overlap, there's always an exception. And I personally tend to organize it to don't have overlaps with different objects because it's more graphical and it looks more organized. But that is something I really keep in mind. We will also look at this concept when we work on our camera angle later. The second thing is we want to keep the image margin clean. So we can see at the bottom image, for example, we have these 3 areas, these three lights, which distract us from our main object. And on the right, we can see we don't have these lights, and then we are focused on our main objects much more. So keeping the image margin clean helps a lot to focus on the main object, on the main focus of the image. Also, you can see here, this area is much more clean and much more organized, whereas this area has much more different objects in this, and is less unorganized. Is less organized. So this is the second, and the third is I want to fill the whole frame. This is something I try to keep in mind quite often, especially with Houdini. I think it's nice to fill the whole frame because it's more immersive. You can see on the right, filling the whole frame, also flying through a simulation with a wide angle lens, is very dynamic and immersive. Whereas we have on the right, we have the same geo, the same simulation, and you can see how much impact it can have to improve your image composition. And of course, there are exceptions, like having establishing shots. It can help to have blank areas, but in general, I try to keep to fill up the whole frame because it's much more immersive. And I also think that many Houdini renders lack on filling up the whole frame. They don't fill the whole frame, and that way they lose a lot. And they couldn't do much better if they would fill the whole frame. So I would also like to I think it's good to keep it in mind. And now I want to conclude. What do you want to express is what you always have to ask yourself. We have more dynamic ways to have our image composition, our main shapes, or more static ways to organize our main shapes. In general, appealing shapes. We spoke through everything, so here you have a conclusion, and we made it now through the image composition chapter. Do you have some questions already?
Any questions, anybody? I think we're okay. Yeah, you can keep going.
Thanks. So now we want to talk about camera, and I want to mainly focus on focal length. You see, we have a wide angle lens, which is below 35 millimeters, and we have a telephoto lens, which is above 70 millimeters, and we want to really learn about focal length now. So let's get into Houdini. Here we have a comparison between our wide angle lens, in this case 16 millimeters, and here we have 200 millimeters, and we see the main difference, which you should keep in mind. The main difference is wide angle enlarges the foreground dramatically, whereas in telephoto, the foreground and background has the same size, they look close together, and wide angle is more dynamic, and telephoto is more flat and also more classy, more static. And keep in mind, if you want to scale up the foreground, use a wide angle. If you want to have foreground and background at the same size, use telephoto. This is the main difference. You can really see the difference, how much it gets scaled up with 16 millimeters. We also speak about specific focal lengths in a minute, but wide angle versus telephoto, wide angle, telephoto, a really strong difference. And now we want to look to some work. So here, for example, we have a comparison with one shot where I used the wide angle lens. We can see super dynamic on the left. Also, of course, we have a wide angle if we fly through simulation, which is quite helpful if you want to feel immersive, if you want to have an immersive feeling. And on the right, you have the background and the foreground. They are quite far away, but they look quite close together because I used this telephoto lens here. We can also check out this comparison. So on the left, we have a really, really strong wide angle. 13 millimeters is extremely strong wide angle. And we see the foreground gets scaled up a lot. We can see it in the beginning of the left shot. Whereas on the right, we have a more flat appearance and it looks more classy as well. So check out now on the left, you see the foreground gets scaled up a lot. And I also want to go with you through the specific focal lengths. And I want to start with the most common focal lengths. The most common focal lengths in photography are 16 millimeters. You can see it on the bottom, 16, 24, 35, 50, 70, 105, and 200 millimeters. These are the most common focal lengths. And it's very good, I would say I recommend to use these most common focal lengths, so 60 millimeters and above. You can see it on there. It's very helpful to use these most common focal lengths because the eye knows images from photography which are made with these common focal lengths, and it looks more natural if you use them in 3D. So if you want to look natural, at least, if you want to have a natural appealing, I typically begin with these focal lengths. You could also use something in between. But now I want to go through these different focal lengths. And the first one is a strong wide angle, 16 millimeters. You see at the moment 16 millimeters, a really strong wide angle, whereas 24 millimeters now is a more natural wide angle. Still some wide angle in there. There's a lot of wide angle in there, but we can compare 16 versus 24, 16 versus 24. And we see 16 millimeters scaled up the foreground again, quite a lot. and 24 millimeters doesn't scale up the foreground so much. So if you say you have an image and you want to scale up the foreground a bit, then you can take a stronger wide angle lens. We want to also look at 35 millimeters. We can see it now. 35 millimeters is a very natural wide angle. And this is especially nice if you want to have a classy wide angle. It's also typical. It's also like similar to the eye. And that's why it's also something which is nice if you don't want to have an artificial look, but a very natural look. 50 millimeters, you can see it now. 50 millimeters, I would really recommend you to not use 50 millimeters, especially if you're a beginner, because 50 millimeters doesn't add much to the image. It's really, I would say, boring. At the moment, we see 50 millimeters. We can compare it with 35, 50, 35, 50. 50 millimeters now it's in fact quite commonly used in photography because it's cheap and because it's also nice for documentaries if you don't want to add something with your focal length, if you really want to stay neutral. But we typically in 3D, we want to have a more dynamic appeal, then we want to go to the wide angle, or we want to have more static, more flat appeal, then we want to go to the telephoto. So 50 millimeters tends to be boring, and I would recommend you to not use it, at least that often. I think it's overused in 3D. Then we can go to 70 millimeters. 70 millimeters now are more flat, but still very classy, natural, appealing. 105 millimeters is a bit longer, and 200 millimeters now is a strong telephoto lens. So we can compare 70 versus 200 millimeters. 70 millimeters has more depth, whereas 200 millimeters is more flat. 70 has depth a bit, and 200 millimeters is more flat, really flat. So if you really want to bring foreground and background together, use telephoto lenses, and especially strong telephoto lenses with 200 millimeters bring the foreground and background closer together. What we now want to look into is the 12 millimeter. This one, woohoo! We can see it really distorts our image. 12 millimeters is an extreme focal length. And if you're not experienced, I would recommend you to stay above 16 millimeters, because using focal lengths which are more extreme, like 12, 13 millimeters, distorts your image a lot and they look more artificial. And of course, if you want to go for this, then you can do this. If you, for example, also want to enlarge your foreground even more, you can use an extreme focal length, like 12 millimeters. But I would recommend you to not use these strong 12 millimeter focal lengths if you are not not experienced, because it can look unprofessional, especially if you overdo it. And I would say it's safer to stay with 60 millimeters and above. So we can see 12 versus 16, super distorted, versus 16, bit more natural, super natural, 24. So that's it for focal lengths. Do you have questions already?
I think we're good. Anyone? Think we're good? Go for it, Justice. You're good.
Thanks. So now we want to work on our shots. Last time we began with setting up Karma. I want to open the file from last time. Here we are. And I want to bring this over a bit. This was our last file. We imported our geometry and we created some materials in different ways. And then we added a light, a camera, and some render settings. So we want to choose the middle stream and delete the other ones. And now we want to work on our camera angle. And at first, if we open Houdini, we always have to go to the perspective menu and go to correction toolbar. And we have to switch to aces. If you don't do this, you have wrong colors, which is not good. So always switch to aces if you are in Solaris and Karma and want to work on the Karma in Karma here. So we want to switch to Karma now. And the way we do this is we go to perspective and simply switch to Karma XPU. So we want to use the GPU and CPU together. And by default, I think it looks like this, because we use this full lighting with shadows. And what we want to do in image composition, it's much easier to get rid of the lighting for a moment, because then we can really focus on image composition. So we can do this with the dome light only. And now we can really look into image composition without being distracted by lights. And we have a camera in here, and we simply want to look through the camera by no cam. We can select our camera and lock it here to our viewport. And that way we can move it with our viewport. And you see, if we look in the view window, we have the default 50 millimeters, which is very boring. That's why we want to change to 24 millimeters. And one really important thing, which we always want to do if we work, I think, in every renderer, also in SOPs, you always want to change this horizontal aperture, because horizontal aperture is the sensor size, especially the width. And typical, most common sensor in photography and also in film is using 36 by 24 millimeters, and the width is 36, and here it's not 36. So having 36 millimeters as a like sensor width is really, really important, because only that way we get an accurate focal length. And we want to have an accurate focal length. And that way we now can start with our image and look for angles. And we want to keep in mind what we learned with image composition. So filling up the whole frame, for example, and getting close. We now can get closer and can look for different angles. Also, I see now, if we get closer, we have clipping. We see we get clipping, and what we can do is we can simply go to a clipping range and bring it down the near clipping range. So we can bring it down, for example, to 0.1 centimeter. And now we see we don't get as much clipping, or no real clipping for us, which is good. What we also want to keep in mind, less is more. So we want to look for an angle which reduces our, which doesn't have too much objects. So let's look for maybe this. I will simply try out, and it's important to take time for this. We also want to add multiple cameras, and then we can choose the best. And we want to play around also with different focal lengths. And something I also want to show you here is, if you make the viewport a bit smaller, then it's much easier, because you remember, having a smaller image lets us focus on image composition, because you get rid of all the details and you focus on the main shapes, which are the ones which count in image composition. And now you can see we can simply play around, move our camera in interesting ways, and and see what could look nice. And we can like try to fill the whole frame. And let's see, I think this is interesting. We can also try to organize our object. So I think it could be interesting to move this shape into this one, into this hole. So let's see whether we made it, whether we are able to do so. But I think then this area gets to, if we go closer to this area, to the right, then it gets too big, and this is something which distracts us from our nice pattern. I think we want to have more similar size in our pattern, because it's more graphical. So we want now, for example, choose this angle, and we want now to make a snapshot. And you create a snapshot by going to this button, clicking it, and then you open the snapshot bar, snapshot strip, and here you can click on this button and you have a snapshot. And that way we can, let's see, we can make right mouse button, click right mouse button on it, and view image. You always have to at first go to this icon, click it, and then we have the color correction strip. And here we want to change to aces. And now you can zoom out even furtherly, which is super nice because you want to really zoom out to get focused on image composition. And you know, I told you that I'm visually impaired. I see 20% vision on my better eye with like lenses, like helpers, and even I zoom out a lot to be focused on image composition. So it's really not important to see the details. For you, you could also additionally squint your eyes and really want to get rid of all the details to, for example, to see how the main shapes look like, because then you can see, we learned about diagonals and we can think about, are there diagonals already? We can see it much better if it's small. And we can, for example, that's why, rotate our camera because we want to increase our diagonals in here because I think it could be more dynamic. Let's try it. But before we do this, I want to show you something because I like to use this render gallery not as a floating window. Oops, I just closed my notes with moving this window. And here I have it again. So what we want to do is we want to add this render gallery to our workspace, because if we close this window, let's do it for now, for a moment, and we reopen it, we always have to redo the aces workflow with changing it to aces, and it doesn't get saved. So that's why I want to add it to the workspace in here in this window. We can add it in here. With the plus icon, we can select the viewer. No, it's the Solaris. In fact, it's here Solaris and then render gallery. I think it's displayed wrong. It's here Solaris and then render gallery. And now we are back. We can switch to aces and last time, and then it stays with aces because we don't close it all the time because it's in our workspace. And now we said we want to try to rotate the camera. Like we can do this by simply selecting the camera, go with the mouse over the viewport and pressing enter. And we can now have these handles and can rotate it a bit. I think it could be interesting to have it that way. Let's see. We also don't want to get too close to the image margin as we are here. So we want to bring up the cam a bit, and we want to create another snapshot. And let's see how it looks like. If we zoom out, it's much easier to see. I think we have here quite some free space. So let's look for another camera angle, because we want to try out different camera angles, try out, let's say 5, 6 cameras, and then we can choose the best. So this is it for now. And we want to add another camera. But before this, I want to show you, if, for example, I say I like this, let's say I like this image better, and we rotated our camera in between. In the meantime, I like this one better, but we didn't save it. The way we could get it back is by clicking right mouse button on the image, and then we can revert network to this snapshot. So this is a way to bring back our networks, because here it's not only the image which is saved, but also the network from Solaris, which is super nice. So we don't want this for now because we want to add another camera, as we discussed. So we want to simply copy our camera with Alt, click, hold, and make it visible. With R, selecting it and press R, and then we switch to the second camera. And let's now use another focal length, like 70 millimeters. It's longer, telephoto lens, you remember it. And we want to bring back the camera. We want to bring foreground and background closer together. So we want to zoom out at first and want to see. I think that way we could. I want to have this shape in the other hole. I think it's easier if we also change the top shape, but we don't want to do this for now because it's time consuming and we don't have much time. So we can also rotate the camera because maybe it's interesting to have it rotate it. I think it's interesting. It gets interesting. So you want a dynamic feeling in this case. I want it at least. So you can see having diagonals, like these diagonals. And you could also say these are C shapes. It's helpful because they give a nice feeling, a nice dynamic appeal. And let's choose an even longer focal length because we can see, like, if we have something closer to the camera, like this area, and something further away, like this, we can bring it further together if we choose like 200 millimeters. And at first we zoom in because we have a longer lens, and then we can zoom back out. I want to do it faster with clicking Alt, with Alt. And now we have this area and this area are much closer together because we have a longer lens. So let's try to make it in an appealing way. And we don't have much time because we want to learn much more different things today. And that's why I don't want to take that much time for it. I think, how about this? In the end, it's always about playing around and trying out different things. And maybe it's this shape. Let's rotate it because it's too close to the image margin again. And it wouldn't be nice to bring it closer together because then we have filled more of the space. And I think it would be more graphical to have these closer together. But yeah, now I messed it up. We can go back with Control C and oopsala, go like you can redo it with, you can also see it here with Control Y or Control Shift C. Here we are. And let us not spend too much more time. I think this is nice to have this shape on this, like to have it overlap with the margin, with the edge, and have the edge, like have this one in our frame, because that way is a bit dynamic. Let's do another snapshot and compare, and then we can select our main shot, which we will work on for now, for our course day. We can zoom out because then we are focused on the main shapes. You can also squint your eyes additionally by, let's say, 80%, and then we can compare. And I really like, I think here you can see now, I just want to add to this image. Here you can see now, I just saw it because I zoomed out that much. Here you can see now these main shapes on the right, they are not as big as the main shapes on the left. And we want to, in this case, I think it would be nice to have an equal yeah, area where the shapes are. So I think here in our other shot, it's much more equal. So I would say, let's take this one, this shot, and we still have our camera, our first camera from this shot, and we can simply look, like make it visible at first with selecting it and pressing R, and then looking through our first cam, and we want to select this shot. We also, typically, we want to try out 7, 8, 6 more cameras, and simply want to copy it further and try out different focal lengths. But for now, we don't have more time. That's why we want to continue with this camera. And we want to also add some camera movement, because camera movement is always nice in motion design. Let's go to the beginning of the frame, of the scene, and then we can go to the transform, and we want to, let's see, let's try to move it back and move it in. I think it would be cool to have this as an starting point. And let's save this in our keyframes. Let's start with this. If we press Alt and click on the text labels of translation and rotation, then we can create a keyframe in here. We want to go to the end of the composition, and we want to bring our camera back. Here we are, and now we can see we bring the camera back now. I personally like this camera movement quite a lot, to move the camera back, because it unveils and reveals areas around the camera which are not seen from the beginning. Like if you zoom in, if you also move in with the camera, then everybody can see what is coming. And this is, I think, a bit more like not as interesting as moving to back. But let's do this for now, and we can see if we moved our camera back, then we can see we created some keyframes in here already because we have these green backgrounds in our input fields. If it's orange or yellow, then we could press Alt and click on the text label to make it green to create a keyframe, but it's already there. And we also want to rotate the camera because rotation is also nice. Let's see, we want to keep it with diagonals. So I think rotating it that way could be interesting. And let's keep some distance to the image margin. So now we see it's green, so it automatically created keyframes. And we want to go back. We want to check our animation, and we see, yes, we zoom out slowly and we reveal this shape up there, which is quite nice, I think. So let's also, let's say if you would have taken another camera, we took the first camera, but if you would have taken the second camera and would have wired it in that way to the camera render settings, you would have to change the camera in here as well. But we took the first camera, and it's still the default camera in the camera area from the camera render settings. That's why we don't have to change anything. But you should keep this in mind, especially if you get a warning from this camera render settings. And now we made it through our camera angle, and we applied our image composition rules and principles, and we learned hopefully a lot. Do you have some questions already?
Yeah, we have one question about color grading.
Yeah.
So I see you have sRGB display and then the ASIS. Christopher's asking about 709. Have you heard of 709? It's like an industry standard with
Yeah.
broadcast. Do you ever use that?
Yeah, I think it depends. If like at the moment we work in ASIS CG with this, and we also want to export in an EXR typically, so we can bring this into a Nuke or into DaVinci or After Effects and stay with like wide color space until the end in best case. For example, I like to do color grading in DaVinci as well, so then we have much possibilities to do color grading with a very wide color space. And then, for example, if I want to export images, then I want to typically go for sRGB. And if I want to export, let's say, MP4, a video, then I typically go for a Rec 709. But it's like there is much more you could say about this topic. So it's a very, very wide area. I'm not sure. Do you have a topic? Do you have a course about
color grading?
Color spaces?
No, I don't. But I will think about it. I hope that answered your question a little bit, Christopher. And then Larry has a question. Does the image ROP and COP save the images in ASIS by default?
Yes, it does.
Okay.
So we will save our image later, but you can see if we render to disk and if we have EXR in here, then it saves ASIS. So we have to have an ASIS. We have to have a config file from OCIO ASIS connected to Houdini. There are multiple ways. For example, I have an environment variable for my OCIO file, or you can put it into your Houdini environment file with a path to your OCIO file. But in general, it's like if you see this option, you are good, and then you can work with ASIS, and then you output ASIS CG and can bring this into, for example, Nuke, and set up Nuke with ASIS default values and work with it properly.
Okay, great. I think that's it for questions. You can keep going.
Thanks. So what we want to do now is we want to explore 2 new features of Houdini 20.5. And the first thing is we want to, let's say, work in OBJ or in SOPs, and we don't have our camera here. It's not showing up because we work in Solaris, and then we don't see our camera in OBJ context. And the way we can bring it over now, it's a new node, is we can add a lob camera import camera, and we simply have to select our camera to bring it over. We have to select the lob path and the primitive path, and we can do this now. So we have, for the lob path, we simply have to copy our camera in Solaris. So select it and press Ctrl+C. You can see in here I copied it. And then we want to go to OBJ context, back to our lob import camera. And here we can paste our lob path. So lob path looks like this, stage/camera1. And we also need our primitive path. And the primitive path is here in the scene graph. You remember last time we spoke about the scene graph, that you have your whole scene in here, and we have also our camera in this cameras folder, and you can simply drag your camera in the primitive path input field, and then you can see we have a new camera in SOPs, which is called lob import camera 1. Let's rename it, let's rename it, let's say we call it like it's called in Solaris, so we call it camera 1, and then we can see we have camera 1, and we can look through it, and we have it in SOPs. We can sadly not change settings in SOPs from this camera in Solaris, but at least we can import it, and it's quite nice. So we now imported our camera with this new feature, and we want to delete it because we don't need this for now. And we want to get into another feature, which is super nice, because our camera has a new lens material in Karma. So we want to go to the Karma tab with our camera selected, and we want now to get the lens material. We can see it grayed out here, and if we want to change something which is grayed out in Solaris, we have to press this circular icon and click on set or create. Check use lens shader. Same here, we want to change lens material, and it's very easy to add a lens material in here. We can simply click this icon. And now we get a new lens material. It's referenced in here. You can see there's a path. And we also get a new node, which is the lens material node. We can organize it a bit better. You remember last time I told you about selecting nodes and then pressing A. And from the point you press A and move the mouse, in this case to the bottom, then you organize your nodes. So you can try this for your own. It's super useful. Oops. And organizing your nodes if you select A and keep A pressed and then click. So Karma lens material, here we are. And now what we want to do is we want to not add a bokeh, it's also cool, but there are many options. We want to go to the lens distortion, and we want to use a curvature map in here, which could be a Copernicus net, a CopNet. And let's bring away our old camera, and we can also delete it for now. And we want to create a Copernicus net in here, and we have to, same way, make it editable, and change the type of curvature to texture map, and then we have to make this editable as well, the curvature map and the amount of curvature. You have to increase the amount of curvature, let's say to 1, so increase it, and that way you see a difference if we put in a texture. And now we simply can create a CopNet in Solaris. So you can create CopNets everywhere, for example in Solaris as well. We create a CopNet and we call it, let's say, curvature. curvature texture, let's say. Curvature map it was called. Anyway, so if we dive in, we see it's a bit annoying because we don't see the CopNet, and we want to have another workspace for working with CopNets in Solaris. And we can set up our workspace, for example, like this. We can bring back this image, maybe a bit, not that much. And then we want to split this pane. We can do this here with this arrow, split left and right. Here as well, we want to split this. And now you have two network views and two parameter views. What we want to have is we want to now go to add a new pane tab on the right top and want to add viewers, want to add a composite view, because that way we see our CopNet if we dive in on the right. We also want to add with plus, we want also to add, let's see why it is not happening. Yes, it works now. We also want to add another scene view because we need it later for lighting. We want to have a second scene view, which can be very helpful, very handy. We will see it later. We want to add it for now as well. And what we want to do is we want to link our network views with our viewports. And one the nice way, or the typical way you do this is you go to this pin, in this case, so this area, and create to click right mouse button, and then you can say I want to link this network view with the number 1, for example. And I can also link the viewport with number 1, so click on this icon and with the right mouse button, and then go to number 1 here as well. So now we see we have these both connected and linked. We also want to link up the network view with the composite view with 2. So then we have another link for the second network view. We can also do this with the scene view, go to 2. And now you can see, let's stay with the scene view for now. You can see if we go to OBJ, for example, then we have another network, and we are in OBJ with our second viewport, and this is linked to our second network view. So this is simply handy to, or important in fact, to link up the right networks with the right viewports. And what we also want to keep in mind is this parameters window. Here it has, if we click right mouse button again, we see last selected node is here active. So what does this mean is we can go to OBJ and change our OBJs with the same parameter view as we can select other nodes in here, because we select simply this last selected node and then we change it in here. So this is like a cool way to only need one parameter view in here. Same with the geometry spreadsheet. You can use it in Solaris and in SOPs. So now we want to save our new workspace, and we can save it when we go to this area. Here we have our workspaces, and we want to save current desktop as, let's say, Solaris, Copernicus, and lighting. Yeah, let's I don't add any further word. I think it's it's quite long already. Let's save it, and then we have our new workspace saved, and here is everything. So that way we can simply dive in our CopNet, which we just created, and we have it in the composite view above the network view, and that way we can simply see both at the same time. We also can see that we got rid of the ACES view. We want to bring it back because we always want to look at our image in ACES view in Solaris if we use Karma. Now we want to add something in our curvature texture, and the way we do this is we simply at first I want to show you what happens if you use like different values in this curvature texture. So at first we want to add a null and want to call it out. And we want to reference it in our texture map input field in the lens material. We can select it and copy it with Control-C. You have the path copied, and we can select our lens material. Here we have it. And before we paste our path, we have to write OP column, and then we can paste it. And here we have our connected Copernicus net in our Karma lens material. And I want to show you if we wire in a constant in Copernicus, we, let's say, can wire in a constant with a value of 0.5, nothing would happen because this curvature map wants to have a black and white image, a mono output, and it wants to have like below 0.5 zooms in and above 0.5 zooms out. So 0.5 doesn't do anything. And if we increase it, let's say to 0.9, we would see that it would zoom out, but it doesn't update. How we can make it update is, the first thing we can try to recook it is we can copy our copnet with pressing Alt and copying it. And you see now something has changed. We should zoom out, but we don't see anything anymore. This is also a bit strange, but we will check out what happened. We can also see we get 2 errors, and we can check them out in the log viewer. So here you have your logs, and let's see, this is the current time. We have a duplicated camera, duplicated item. I think maybe this is not the case here, but maybe it's 2 Copernicus nets. What I want to do is I want to go to parameters view. I want to see, we are back in lighting mode. Maybe that's the case. So we were in dome light only, which is the default dome light, and we were back in lighting mode, and that's the reason why it was dark. So we want to get back to Karma and want to look through our cam. And now we see it. Now we see how our image has zoomed out. You remember, without the texture map, it's the camera angle which we choose. And if we have the texture map with, in this case, it's also zoomed out a lot. We can also frame our nodes, our objects in the viewport as well with G. By the way, you can also frame your image in the in the composite view with with Shift G. So this is quite handy to know. And now we have a white color, and we can see 0.9. It's zoomed out a lot. If we have a dark color like 0.1, something which is below 0.5, we would see that it zooms in, but it doesn't update. What can we do? We can alt click and recook our copnet again with this. So we see now we are zoomed in. So this is a way to use the copnet. At the moment, sadly, it doesn't recook by itself all the time. It's a bit unstable, but I'm sure that it will change in the next release. Like at the moment, Copernicus is still in beta, and we have 17 days after release from Copernicus from Houdini 20.5. It's July 2024. So that's the reason why at the moment we have to force it to recook. I'm sure that in some releases it will recook by itself, and then we can change colors and textures, and it will recook by itself. If it doesn't recook, also not with clicking Alt and copying it like this, then we could also change paths in the light in the lens material. And if we change, for example, the path to the main Karma, to the main Copernicus net, we can also delete the slash and bring it back. If we have error, if we have problems with not updating image in this curvature map input, with our Copernicus net, this is a way to simply change our paths in the curvature map, our reference path, as until it updates. But now we want to add a nice texture map in here, because now we know how it works. Below 0.5 we zoom in, and above 0.5 we zoom out. And you know, we can have a nice image texture in here, which is not the whole, like at the moment it's like constant, it's super boring. We want to make it interesting. We want, for example, we want to add a Julia fractal. A Julia fractal is very interesting. You can see it on the right. Here, this is a Julia fractal, and it gives very unusual results, which come through the Julia fractal mathematical formula. It's a fractal, one of the fractals in mathematics, and it gives really interesting patterns. And we have it implemented in COPS in Houdini, which is very nice. And there are like similar fractals as well, like the Mandelbrot fractal. This is 2D. You also have a 3D version of Mandelbrot, which is Mandelbulb, or a 3D version of the Julia fractal, which is Julia bulb. So in general, it's something you could Google because it's nice. And we want to wire this in. We want to wire this into the out. I want to see whether something is happening. And we don't get it updated. So we want to change, we want to at first copy our copnet and with Alt, and we see something changed. So let's say, I think it should look different. I think it should zoom in extremely on the outer parts and zoom out extremely on the inner parts, because we have really strong black and white map. So we want to change our path. Now we see it updated. Like, it's a bit strange at the moment with the beta in Copernicus, but we can simply change our path if it's not updating, and then we have this update now. And we see this image on our, we see like the stretching a bit, but it's not nice yet. We also see that we have like a square image, and we see it gets stretched over the whole image ratio or aspect ratio of the camera. We want now to make this fall off. It's very, very strong contrast. You can see it's super sharp edge. We want to make it much more smoother, because then we can see we have a really smooth area where it gets distorted. Let's do this with a blur. We can simply add a blur and add the blur, let's say, bring it up lots to 0.1. We can see it's very blurry now, and it doesn't update again. So we can change and say our paths, simply add a slash. Ha, here it updates again. So it's a bit strange behavior at the moment, but we see that it updates. And we see it looks interesting somehow. I think we can do better, but it's interesting to have something in the middle. In fact, it doesn't look that strange. And I think it looks quite interesting somehow as well. But we want to have a more immersive distortion. So we want to simply increase, or want to fill up the whole frame with the Julia fractal. And we can do this with a simple transform 2D, scale it up. And here, scaling it up with a uniform scale in the transform 2D, let's say by 3. And now it's really big. Let's say, it's 6. That's the reason I wanted to have 3. And if we have 3, we also, let's see if we change the frame, it also updates. So multiple ways to update this Copernicus net in our Karma lens material. And you remember, the value of the pixel defines how much distortion we get. So we can also decrease the contrast to bring down the distortion a bit, because I think it looks really interesting at the moment, but it's a really strong distortion. So let's use a remap to decrease the contrast. And we can do this by bringing up the left point and bringing down the right point. And you can see on the right, we see, yep, we have lower contrast. We want to update. Let's move the frame. And I think it updated already. Yep. We get less distortion. We can simply, in the end, you really want to look on how does it look like. and what do you like? I think this is quite interesting. It also is nice with our texture from last session, I think. So what you could achieve with this is you could, for example, have this result if you are directed a bit furtherly. So in the end, it's really something to take time to also, what you want to do is we don't have time for it now, but you want to click the flipbook and then you can say, let's say we want to decrease the resolution by 50 and we want to only render every third frame that it's faster, and then you can hit start and then you get mplay to render a preview with our distortion, and that's the way to preview our Copernicus curvature texture with distortion. But we don't want to do this for now because we don't have time for waiting until we see a result. You can simply trust me that it moves in nice ways, and we see, yeah, we can also check it if we scrub through the timeline. Now whoopsala, just have to go back to my notes. Now we made it through the new versions, the new updates of Houdini 20.5. And do you have questions? Did you write something in the chat already, or what's up?
We are saying how cool this is. This is awesome. Any questions, anybody? This camera distortion trick is really neat, and I love how the Karma lens material, you guys can use Copernicus in every area that says texture map. You can put Copernicus. So cool. I think we're good on questions though. You can keep going.
Amazing, thanks. Yeah, I think it's also really, like for me, it feels like a big innovation with Copernicus, especially with the slab comp, which we will learn about on day 3. And I think it has also advantages with this distortion method, because if we would use the slab comp to distort our image, we only have the edges of the image, so it can't look beside the image or beside the frame. And here we have the ability to look beside the rendered frame, which we don't have in the slab comp, which we will look into on session 3 next week. But now, what we want to learn now is we want to get into lighting in Solaris, and we want to learn about 3 ways how we can do lights in Solaris, how we can set up our lights. And we simply bring back our lights, I would say. At first, I would also undo the text, like I would undo the distortion, because then it's easier to do lighting. You can switch it on in the end if you want. And we have a light in there already. And to see this, you remember, we went with the default dome lights only. And we want the full lighting with shadows if we want to work with lighting. So that way we don't see anything because it's very dark, the light, and we didn't set up anything yet, but we see light, I believe. Let's check. Let's move out. Let's move the viewport and we can see light. Our first light, which we didn't change yet, but here it is. And you have cool lighting methods in Solaris. I want to show them to you. So at first we could also bring our lights down in the network here. It doesn't matter. You only have to take into account that if you select a node, let's say the camera, and the light is below the node where the view flag is, then we don't get lighting. They don't get the nodes which are below the stream if we have the view flag before them. But if we have the view flag, let's say in the area light, then it doesn't matter whether the area light is before the camera, or we could also, I can show it to you. We can also have the camera active and the area light before the camera, and looks the same. So in the end, that's important to know that how you wire it together doesn't matter that much, doesn't matter at all. So you, like in this case, we want to organize this network a bit furtherly, and we want to get into lighting, into our methods, how we can do lighting in Solaris. And we can do this simply by selecting our area light and go with the mouse over the viewport, press enter, and now you have light tools. And the light tools are very interesting because you get many options in here. You can also show the options by Shift F1. I want to explain the most important to you. Like Shift F1, you can bring in all the details, and we want to have more image space. That's the reason I want to hide it for now, but I want to explain it to you. So we have our lights. Here it is. We have selected it and pressed enter over the viewport. And what we now can do is we can increase the intensity in the viewport if we press Control and Shift. We can press Control and Shift and click left mouse button, keep the mouse pressed and move the mouse to the left and to right. So you can really change the light intensity with simply having the mouse over the viewport, Control Shift pressed at the same time, and click with left mouse button and move the mouse to the left and the right. And that way you can change your intensity of the light. It's really cool. You can also keep everything pressed, Control Shift and left mouse button, and then you can scroll, and then you can change the increments. You can see the increments. You can also bring up the increments extremely much. If you, let's say, the light is extremely far away, then you have to increase the intensity and a lot, and then you can make it much more faster if you increase the increments. So let's bring it back again. Let's see whether we make it. Let's go to 0 and want to decrease our increments. Yeah, we want to bring it down. I think it's better with like this increments. So this is now it's really dark. We want to bring it up a bit, the intensity. So Control Shift to change the intensity. The next one I want to show you is you can change the distance by pressing Control only and left mouse button. So left mouse button, move it to the left and the right, and press Control, and you see we can change the distance of the light. And it's super cool to change this in the viewport with Solaris only, sadly not in OBJ. But you can also do this in different renderers. If you don't use Karma in Solaris, you can also use other renderers in Solaris. You could use these tools. And I want to show you something else, because you have these modes here: edit, specular, diffuse, and shadow. And if you stay in diffuse, you can at first select an area and diffuse highlight. So let's say you want to have a diffuse area in here, and you want to select this spot, and then the light, like you get light on this area where you click. And this is quite cool by itself already. But if you now use the tools which we learned, I want to move the viewport a bit that you can see the light and the shape. If you now have the diffuse mode active, so you selected an area where you have a diffuse spot, and if you now change the distance again, we can check, pressing Control and change the distance again, we can see we increase the distance super far, and it keeps the brightness on the object. So it recalculates the brightness in diffuse mode, which is very interesting, very useful. We can also check if we are in edit mode and increase the distance with Control, it gets dark because it's further away. But if we are in diffuse mode, and if you clicked on an area and then you increase distance, it keeps the brightness. But you have to see this blue line at first, because you have to select a diffuse area at first, that it works to recalculate the intensity on the object. So this is super cool. And we want to also look into the other modes here, like specular mode, for example. Here you can select a specular area. So let's say you have this area and want to have a specular highlight in here. Let's simply click. We are in specular mode, and you have now this specular highlight in here because we clicked on there. Let's simply click on these areas, and we can select these specular highlights and add them to positions where we like them, which is really cool. It's especially nice, I think, for eyes. If you have a character and you want to have reflection in the eyes, then you can add this by this specular mode and simply click on these objects. And now we also can look into the shadow mode. The shadow mode lets you create or lets you set up shadows. Let's take this angle and we can see we click at first and we get this first circle, and now we have to press shift and click a second time, and then we can move our second point of the shadow. So you can simply select where the shadow should be, where the shadow should move along. So this is quite cool because you also have another nice mode for doing lighting. And we want to get into some more details with this lighting mode, because in edit mode, we didn't speak about this yet, you have the ability to, let's say, you can press, you are in edit mode, and then press Shift T, and then you can decide where the light should look at. I also want to see the light. Here we can see the light and the object together, and then we can see, we can click on the object, and we can select a look at position, which is nice. And there are some handles. So we can simply use these red and green handles to move around the lights. And it always stays with a look at this point. The red and the green arrows let us moving the light around. And the blue arrow, you see this as well. We can see the light and the arrow as well. I think that way we see it better. We can rotate the light with the blue handle. Look on the light, and I move the blue handle. We can see, woohoo, we move the light and rotate it around, which is nice to rotate the light here with the blue handle. So we get lots of control. We can simply rotate it with the look at. We want to get out of this look at mode by pressing Shift T again to go into look at mode, and Shift T another time to get out of look at mode. One last thing I want to show you here. So we have our light and our light tools. And one thing I want to show you, if you are in edit mode and press B, then you can change the width. And if you press B again, then you can change the height. And if you press B a third time, then you are back in normal mode. So then you are like you have closed the you have closed changing the size. So one time B again, width is changed by clicking left mouse button, by the way, and pressing B the second time. We can simply move the height by clicking left mouse button and pressing B a third time, and we are again in our normal lighting mode. We can also, by the way, we can also click or also check normal power in our lights, basic properties, check normalized power, normalized power. And then if we change the size now with B, we see it doesn't get brighter, or it doesn't change the intensity. What it does without checking normalized power. So normalized power can be quite handy as well. Now we learned about the Solaris lighting tools, which is super useful. And I also, at the same time, side by side, I also tend to use the old OBJ lighting tools, because for me, I get more common lights, more typical lights with the lighting tools in Solaris. And with the OBJ lighting tools, where you look through the lights, there you, at least I tend to get more unusual results, sometimes unusual results. And we just added another scene view. You see here the scene view, which we added to our workspace previously, and we can go to the stage with our second node tree, second network view as well. Then we have the stage in both network views, and here we have our scene view, and we can simply with the second viewport, can simply look through our lights again. So we can, let's say, go to no camera in this case and look through our area light 1 in this case. We lock it to the viewport and then we move the viewport to move our light because it's locked to the viewport. Now we see on the right, we see our image. That's also typically we want to look through our camera on the left, and then we can use this method to move the light. It's a bit dark, I think, but then we can simply increase the power, increase the intensity by pressing at the same time pressing Control and Shift and moving, clicking the left mouse button and increase to increase the brightness if it's too dark. But now we can simply, like you see on the right, we have these exact same lighting tools from OBJ by looking through the light if we have a second scene view, which is very handy. And this is something I use, I would say, 20%. I use the lighting tools also 20%. And 60%, 60% of the time, I use the third method, which is something I will show you now. It's common in OBJ context with the sub-renderers to attach a light to a null, to rotate it around a null. And sadly, it's a bit harder in Solaris, and it's not super hard. So that is the reason I want to show you now how you can rotate a light around a null, because that is something I use, I would say 60% of the time I do lighting. So let us attach a light to a null. In this case, this light. Let us attach this light to a null in Solaris and look on how this works. So we simply need 3 nodes for this. At first, we have the light. This is necessary if we want to move it around a null. Then we want to add a primitive lob, and we want to add a transform lob. And we want to wire everything in. And what we want to do here is, you can see on the left, we have our scene graph. And we have the whole scene organized in our, I turn them off again because otherwise we get them already previewed in here, but I want to explain before we get them previewed. So if we have our scene here, we see we have a light, for example, a light path or the light object. It's also called a primitive. So this area light 1 is in this location, and what we want to do now to rotate this light around is we want to create a primitive for this area light 1 at the exact same position before we create this light. So if we select the camera, we don't have the light. You see, we don't have the light yet in our scene graph path, in our scene graph here in our hierarchy, because the light comes under the view flag and it is not activated because the view flag is above the light. And that's the reason why we want to, that's the reason why we don't see the light here, which is like, it makes sense because we didn't add a light in here. But what we want to do now is we want to add a primitive. We want to now make it visible and make the view flag, change the view flag to the primitive. We want to create a primitive at the position of the light. And the way we do this is we simply select the light we want to rotate around with the null, and we go to the primitive path, and we want to use this primitive path and want to create a primitive with the primitive lob at the exact same position where the primitive path of the light is with the exact same name. So what we can do here, we can see there is an expression which is called $OS. What does it mean? It simply means that we have referenced our node name. We can also preview our expression with middle mouse button, click on the label, and we see, yep, we see this is area light 1, $OS, which is the name of our light. So what we want to do now is we want to copy our primitive path of our light, copy parameter, right mouse button, and then copy parameter. And then we go to the primitive lob, and we can paste our primitive path. And we can paste it, right mouse button on the label again, and then we can paste relative reference. And we can again preview with middle mouse button on the middle mouse button click on the label text. We can preview, yep, we see light / area light 1 was the primitive path of the light. And if we now go to the scene graph, we can see there is a primitive already for this light even before the light gets created, which is not necessary. We also want to then have a transform and want to always, if we transform something in Solaris, we want to paste the primitive path of the object into this primitive input field. So then we can only transform it. You could typically, you want to drag it over. We want to reference it. Reference it. We can simply do this with the right mouse button, and then we can paste relative reference because we can preview with middle mouse button. We still have our primitive path from the area light copied, and then we have our transform and our area light. And now you can see we have our area light. We want to see our light and the object, and we want to see whether it worked out. Did it work what we just did? Does this transform move our light and rotates, for example, our light around the null position if we have the translate as null? So let's rotate and see. Yes, it works. Woohoo! We have our attached null to a null, our null attached to a light in Solaris, which is very nice. And that way we can work very efficiently in lighting and can try out different light positions, which we will do later in the course today. So that is super easy to rotate the camera around the null. It's the same technique. So I want to make it in quick now. We simply need a primitive. We then need a transform. Then we need a camera. Let's create one and go out of the center with the camera so we can make it visible at first. And now we want to move our camera to lock it to the screen, lock it to the viewport, and we can move it away from the viewport. And what I show you is now we do exact same thing as with the light, because it's the exact same technique. This is our camera, and we want to now copy our primitive path with the right mouse button, copy parameter, and paste it to the transform with right mouse button, paste relative reference, go to the primitive paths and paste our relative reference to the camera. And we can also preview with middle mouse button, yep, camera. And now we can rotate our transform. So let's look through the camera, let's say, and we can transform our camera with the null. And we see, yep, it works. It's super easy. You only need a primitive transform in the camera or the light, which you want to move around a null, or in this case, a transform. So that is nice. That is our third way how we want to do lighting. And yeah, I think this is, at least for me, very useful. So I want to delete the camera because we don't want to use it in this case. We want to make the light visible again. And now we learned about the fundamentals of how we could set up lights in Solaris. Do you have questions?
Any questions, anybody? I think we're good.
Great. So then we learn about basics of lighting now. So how can you improve your lighting? And what's the most important things you have to keep in mind? So the first thing I want to teach you about lighting is take time for lighting. This is the first advice. But now we get into, I think, the most important chapter in lighting, which is you want to see how light behaves. You don't want to use default lighting setups, but you really want to move the light around and want to see how it behaves. And we can do this simply in Houdini. I've got a demo file in here for light, and we can like attach our lights to a null as we did already, and always have to keep a close look on what happens if we rotate it around. And this is everything you need in the end. You only have to see what changes if we move the light, with the goal of we want to shape the objects. We really want to see in what light position is the object's shape emphasized. So this is the only thing you want to keep an eye for. If you move this light around, you typically work that way, or I work that way, that you attach your light to a null, and then you can exactly see, if you rotate it around, what happens with the shape, what happens with the lighting. And of course, it's important to play with different lights and take time and change lighting until like try out different lights as well. And what you also want to have here, you can see, is you want to have shadows, because shadows give depth. Shadows really shape the object. But in the end, it's nothing more than seeing how light behaves. It's also easier to see this if you make your image small again, then you are focused on the main lighting differences, which are the most important ones. And that's really it in the end. We learn more about it, but it's nothing more than looking closely, really taking a close look on what happens, on what changes, and how you can emphasize the shape of the light. And what we want to do now is we want to look, for example, in this image here, I also rotated the light around the null, and then I saw at this light position, I see that the main shapes of the face are emphasized. And this is the reason why I took this light then. So you can also see it better. I already said it, if it's close, if it's small. So now you really focus on the main light areas or bright areas, and really don't get distracted by details. Make your image small, because it's much easier then. I said you don't have to, or you shouldn't be afraid of shadows, because shadows give depth. Here's a good example. I want to go through some images of David Newton, because he's really a master of light, and he also, you can see, he emphasizes the shape with small lights. And it's as easy as it sounds. Like, you simply rotate it around and taking a close look, and then you can see at this position, yep, my shape gets emphasized, and then I take this position. So, for example, here we also have shadows to shape our objects. So, like the petals, they have some brighter areas and some shadow areas. And if we wouldn't have these shadow areas, they would look super flat. But we have these shadow areas, and that way they have really depth. So we want to emphasize our shape also with shadows, also with small highlights. And here, for example, we also see some shadow areas help a lot to give depth to our, also in this case, quite bright scene. So having a bright focus point in the middle, this product, and then some shadows around can help a lot. This work by Man vs. Machine, you can also see here they really emphasize the shape of this bag by the light. And you really have to look closely with when you move your light, when you change your light, when is the shape emphasized. And I personally had the luck to learn this technique from Greg Gorman, who took these images. He does it in the exact same way. And that's the most important thing I learned in 14 years photography. So he teaches in his workshops also to simply move lights around in the studio and then look closely on what happens. And then you see, for example, this shadow looks nice if we have exactly this light position, or this in this light position, the face gets shaped very well. So in the end, it's really about taking a close look. This is what Greg Gorman teaches in his workshops, what I had the luck to get taught by him, and what I also think is the most important thing to keep in mind while in doing lighting, to take a close look and simply look what happens with your lights when you move them, and don't use only preset setups. So now we want to explore some light directions, because it's important to know what light directions do. At first, we have a light direction. You can see it here, where the light is directly behind the object. The light is directed straight at the camera, and it gives us super dramatic lighting, which can be nice if we want this, and it's at least interesting. It's really like I would say a good light direction. So this is something you could do: put your light directly behind the object and have like this position, like on the right. You can see it. Then we can move our light around. We see we have, for example, here also a nice light position where the light comes from the side light, and here we have also a very interesting position where we get the object, where the object is shaped, and where we get shadows on the object, and we get like the shape is still emphasized. And if we move our light around, then we have like, at the moment it's still interesting if we have like an angle of, let's say, 60 degrees at the moment with camera and light. We have at the moment an angle of 60 degrees. It's still interesting, but it gets boring from an angle like, I would say, 30 degrees. So if you have especially the light directly behind the camera, like it is now, on the right you can see it, the camera and light position is exactly the same position. It is really flat light, no shadows, and it's super boring, which you don't want. You want to have the light at least, I would say, 30 degrees between light and camera to get some sort of shaping on the object. So in this case, for example, you could have the quite small angle between camera and light if you want to have a more high key image. And if you want to have a more dramatic image, you still can go to the side light, like here. And I want to also give you like the name for how it's called when the light comes from behind. It's called backlight or also rim light. A rim light, I can show it to you here. Rim light, like RIM light, is typically like this. Then the light is directly behind the object. Also, the sun could give rim light. And also here you can see a very interesting example of where we have not a rim light, not a typical rim light, but the position is the same, that you have like 180 degrees between camera and light. So we have a backlight. The light is directly is directed straight at the camera. And you can see it here. We get really nice reflections, a nice dramatic mood, which is super interesting in our image and gives much. It gives a moody image. I also want to show you like side light image. Here you have an image where the light comes from the side. Here you can see the reflections and the shadows go to the opposite direction. So the light comes from the left side. And you can see that gives also a very like dramatic, yes, but also interesting image. So having side light, backlight, or angles above 30 degrees between camera and light is really interesting. What you don't want to have typically is unnatural lighting from below, because natural light, like from the sun, comes from above or from the side with the sun, and the sun comes never from below. You can see it in this portrait that it also, like, you can use it for horror effects. You have to have an light from below or to have an irritating effect. But I would really recommend you also an abstract animation, also an abstract motion design, to not use light from below. So now we want to combine different directions. So let's say we combine backlight and have a fill light in here from the side as well. You can see backlight is stronger and the fill light comes from the side. You can see the result. Here it is. And this could be a starting point. As I said, you always want to move your lights around and wants to see what happens and then choose the best angle. You never want to use these presets, these setups, but this could be a starting point to combine these directions. Also, we can go for this side light setup where we have light from both sides, as I said, not the final lighting, but something where you can begin with. So now I want to show you something else, which I really like to do in lighting. Let's go for 60 frames. Let's go to 60 frames and switch to 0. And we have flat light again. But what we can do, what I also like to do a lot, is to use a spot. We can select our light and go to the shaping tab and click on the spotlight. And we have to decrease our, we have to bring down our angle. And then we see, after some time, we see now we got a spotlight, which is really nice because we have shadows again. And we can really art direct the lighting because we can say, we can, for example, select a specific area of a product or of a simulation where we want to add some further lights to emphasize the shape. You can also rotate your spotlight around. It doesn't have to come from a boring light direction, but you can see the spotlight is the first option to increase shadows and to like narrow down your light. The second option we have is in here. We have also the barn doors. Barn doors are like an obstacle on the left and on the right, also on bottom and top. You can scroll down and we see it. We can, for example, have something like a strip if we have 2 barn doors. So they are really useful because then you can also say, I want to get rid of some of the lights because you have maybe some parts of the shapes which get too much light. And you always keep in mind, you always want to have shadows. And that is the reason why we want to also use these barn doors, use these spotlights. So now we want to see how this could look like in our previous setups. Here, for example, we have our setups without a spotlight. And what I like to do is I like, for example, to not have a fill light everywhere, but have a fill light only in some parts, like here. We compare this version where we have a fill light with a spot with our first fill light, which has light everywhere, which is a bit more like it doesn't shape the object as good. Whereas having a spotlight in our light can help to add some shadow and get some variation and bring in some variation. So now we also can check out what happens if we bring the spotlight to the backlight, to the rim light. Here we can see it's even more dramatic depending on what you want to achieve, but I think it's good to use spotlights in your work because increasing shadows can give depth, can also increase dramatic effects like you can see in my work probably. But in general, it's something which I would really recommend you to keep in mind. Next setup, here we have been without spotlights, and if we bring in spotlights, we can see it's much more interesting now. Without spotlights and with spotlights, we really get much better result with taking away some light. So subtracting some light can really help as well. For example, by using the spotlights. And I also want to show you an example how I like to use the spotlights in my work. And here it is. In this work, for example, we have a spotlight in the middle, and you don't recognize it until I turn it off. Without spotlight, with spotlight. Without spotlight, with spotlight. So you can see I also use spotlights in a less obvious way. For example, to emphasize, in this case, center, to have a main focus. And this is very helpful because you're really, really focused with the spotlight. And you can really change small parts of the image and emphasize some other shapes or make it more bright, and then you have more focus on this area. If you only have the spotlight, like in this case, this is spotlights only, which are used here. So you of course could also use the spotlight in creative ways. For example, here in images like from Paulina Washington, she has really amazing examples also with artistically used spotlights where they are very obvious. But in general, I think they are a great addition which you should use in your renders. And now we want to get through some more basics of lighting. So we want to learn about how we can influence the shadows. Here we have a setup, and we want to learn how can we make this shadow more soft or more hard. There are two main options. So the first option you have to increase the sharpness or the softness of the light is by changing the size. You can see on the right, there's my setup, and on the left, you see the result. So I changed my size of the light. Let's say I use the B again, and then I can click with the left mouse button and make it big, and you see super soft shadows. I also bring down the increments, and then I can see if I bring down the size, in this case the width, it's super sharp. The shadows are sharp now. We have control. Soft shadows, sharp shadows. And we want control because we want to interact. And we want to find the best solution for our image and want to emphasize like image composition and different ways. But here the first method is changing size. Changing size to really change the softness, the softness of light, because this is the first method which we want to use. Now, we also have a second way, a second method which we can use. I make it a bit bigger before. So we want to have it soft for now. And the second method is to use distance. We can simply use distance by, in this case, pressing Control. And we have a far away light now, which gives us sharp shadows, whereas having a close light, you can see on the left, on the right, here the light is very close to our scene, soft shadows. Further away light, sharp shadows, close light, soft shadows. So you can see two main things you have to keep in mind if you want to change the softness of shadows, which is the size of the light and which is the distance. So that is the first thing. And the second thing I want to talk about now is we want to talk about fall off. So we want to get everything set up. And here now we see our scene with a really strong fall off in light. And this is typical, this is common in lighting because you have lights have a really strong fall off. They have, in fact, quadratic fall off where you can see if you double the distance, every time you double the distance, you only get 1/4 of the intensity. So if you have here, let's say intensity of 1, then we have here 1/4 and here 1/16, and so on, 1/64. It gets dark quite soon. And what can you do if you want to have light in the whole scene? You can simply increase the distance. So if we increase the distance, then we can see our whole scene is now with this like in lighting in this exact same brightness, which we like. The fall off doesn't affect our scene as much anymore because it's so far away that it doesn't matter that much anymore. So if you want to have a strong fall off, bring your lights close. If you don't want to see any fall off in your scenes or in your objects, then you have to bring your light further away. So this is something you should also keep in mind to change your lights. And now we made it through the basics of lighting. And do you have a question?
Any questions, anybody? I think we're good. Yeah, keep going.
Thanks. Amazing. What we want to do now is we want to go back to our old scene and we want to do lighting. So here we are. And as I said, I really like the attached null, or in this case, the transform with the primitive. And I like it because, as I said, we can rotate our lights around. In fact, I like this lighting already, but it was not intentional in this case. But I want to show you. Let's make it a bit bigger because I think it's nice for the course. Even though you can remember, I like to work in small images. We want to make it bigger for now because then I think it's more immersive for you watching this course. But I like to work with small images. So we want to rotate our light around. Let's say we add a light to our scene. We have something already, but then we have to move it further away from the center. In this case, it's moved further away from the center already. And then we can rotate it around our center. And we simply do this now. And look closely what happens. So we can simply take rotation and take a close look. Ooh, this is nice. In fact, this is very fast result. I don't like typically I try longer to get a result which I like, but I really like how the main shapes get lit in here, on the left and on the right. In fact, let's save it for now. We can let's try something. Let's try a bit furtherly before we finish. But we want to add many lights, and we see. I think I also want to describe what I see. So if I rotate my lights around, I don't like these positions like that much because it's flat. We don't have the shape. It doesn't get emphasized. In this case, for example, I like the left because this gets emphasized, and we can also rotate it furtherly around and can look how it looks like. For example, on the right, I like the lighting now because the shapes are emphasized. We have like these main fingers of our composition, and this is like it gets some shadow and some light, which gives depth. And on the left, I think it has too much light, so we don't get that much depth and that much we don't emphasize our light as much. I like the 60 degrees rotation, and I keep this as my first light, and I want to try different lights. Like, let's say we add 10 lights typically. In this case, we may don't add that many, because we simply have a limited time. But if you work, add many lights. Let's say add 10 lights, and then you can say you like 5 of them, and you can enable only the 5 and try which is nice to enable together. So at first we simply add different lights, and we want to also, while rotating, this for example is super boring because now it's very flat. But if we rotate it around, oh, this is interesting as well, isn't it? Especially in combination of both lights. I think we have to keep in mind that this should get some shadows. So I like how these interact, how this reflection and these other reflections on the left and the right, they are similar, and then we have like some sort of repetition, which is also nice in design. Here, if I rotate it further around, I think it has too much light on these inner parts. But if you go back, I think it's fine. So we simply want to find the best angle. I think this is good because here it's quite narrow. It's still quite big, but it has shadows and has pronunciated shape. And this is our second light, I would say. So let's add a third light. Let's copy it with clicking Alt and pressing Alt, and let's bring down our render settings further, and then we can wire everything in. And here we are with our third light. We do the exact same thing. In the end, I don't want to bore you, but this is the way how you work. Like here, I don't want to add too much light because then we get shadow. Then we don't have depth in our shape, and we really want to emphasize the shape. But if we want to, for example, have reflections on there as well, it's also very interesting. I think I like how there are smaller reflections below. What I also every time want to do, I didn't do this yet, is I want to change the size. I want to look how it looks if we change the size. So let's say we select our light, go with the mouse over the viewport and press enter. Then we see we have the light tools. Then we can press B, you know this already, and we can change the light, change the size. And we see we want this small reflection, this rim light, and that's why we want to keep the size bigger. This is too small. We see we lose our rim lights, and if we go back, we have our rim lights, our small lights in here. Let's also change the height and see what's happening. We have to click and with left mouse button and move the mouse to the left and the right. It doesn't change it that much and at all. Don't know. But I would take this for now. I like this. Let's also go over the size of the other lights. We have simply to select them, and then let's see. Then we can select. Then we can press B again and change the size. The width doesn't change anything on the right. I think that's the light we are just changing, and having it smaller. In fact, I like to have it bigger because it gives some contrast between the lower, harder, really narrow narrow reflections and the stronger reflections in there. So I think it's, let's see, this is I like to have it in some parts and don't have it in other parts. So this is too big, I think, and this is fine for now. You can also see it has a really big size. It's simply because our scene is also very big. We have like these shapes in 10 meter by 10 meter or so. So it's like an architectural shape, architectural building size. But I think it's fine for now. But that is the reason why our lights are that big as well. So having these different sizes, we can also try. Yeah, it doesn't change that much in this case. But you can see this time, for example, take a close look. And then you can see if I change the height, we get much more reflections in here. And if we bring it down, much like we don't have that many reflections. So I think this is quite a good middle area. I don't like to have it that much because then we don't like, it's also okay, but I think there is a nice more contrast if we have this in the middle and don't have super big or super narrow reflections. So we could add many more lights. I would also do so. We could also activate the spotlights and look what it does. And we see we lose our reflections there. So that's the reason why we don't want to use the spotlight in here. But this is something which we really should do. We should play around, add 10 lights, and then we can see if we if we bypass this light, for example, we can select it and press B. How does it look like? Does it look better or worse? I think in this case, we need it because it's a nice combination. And if we don't have it, it's too much shadow. But if we have it, if we have it, it's nice. So that's why I think we need all lights because we didn't try that many lights. But if we would have 10 lights, we can simply switch some off, switch some on, and then we have our best light combinations in the end. But I like to do also, because we work in animation, here I want to work in one frame and then I want to try, does it still look like it look good with the other frames? If it's not looking good, then we can move the lights and if it still looks okay, then we could keep our lights that way. But what we want to do now is we want to zoom out again, because zooming out is so much easier to see all the composition and lighting. Simply show this snapshot bar and we can press our snapshot button and go to our render gallery. You remember it didn't save ACES, but it typically does. So I think it was because we saved our workspace. And we want to select our image and we see, yeah, I mean, for this short period of how long we worked on it, we didn't take time at all. Typically, I would really take many hours for finding the better composition and light. But in this case, I think it's really good result for the short time we had. And what we want to do now is now we want to bring in some textures because we do motion design with Copernicus, and that's why we want to have textures in our lights. In fact, you anyway, in general, you typically want to have textures because they increase realism. They simply are there to not only have light in the exact same brightness over the whole image, but they are there to, if you have the texture, then you have variation in brightness in the light. And this is something which we can create with Copernicus as well, of course. We can simply add a copnet, call it light texture, and then we can dive in. Let's do it with the other node, graph or network view, and then we can go to the composite view again, and then we have our Copernicus image here as well. So we can simply add something. I would add a ramp. I would add a ramp because it's easy to have a typical texture of a light with the concentric ramp. If we invert our image, our ramp, then we see with this button we can invert it, our ramp. Then we can get a typical light fall off, which is quite nice. We can also increase it a bit, that we get more light in the center. And this is like a typical softbox in photography. Maybe some of you know this, that they also, like, they are not exactly white everywhere, but they have some variation because I nearly would have said it's nature, but I think softboxes are nature. It's like real in photography, for example, you have some sort of like in the light formers, you have different parts which get more light and some which get less, and we want to mimic this in 3D. So we want now to add a noise to bring in some more details. I make it visible with selecting it at first and then go to R. And we want to increase the size drastically because we want to have like really major differences over the image, because you only see like major differences in the texture. All small details get blurred out in our light texture, because I think especially because the lights are that big. That is something now which we want to combine. So we want to combine the noise and the ramp. We can simply do this by multiplying it, because multiplying it, you know, if you multiply something, then if it's 0, like the black areas, multiplied by 0 gives 0, so doesn't multiply it. And then you simply only apply to the white parts, because you can multiply, for example, 1 with the pixel values of the noise, and then you get the nice multiplication of both. And what we want to always do is we want to attach a null. So we want to type null and call it out, and we want to copy it by Control-C. You can see on the bottom here, Control-C is what I pressed. And we can now go to our lights and paste it in. But before, we always have to do the OP column, and then we can paste it. And we probably get much darker lights because we have no perfect white areas and we have a bit darker texture, but we can see what happens. Let's paste it to all our lights and increase realism by this. We see we get darker image now, but we can simply increase the intensity of our lights. Ooh, we get really darker image. Yeah, that is what happens. But I also want to show you here, if you are distracted by the lights in the viewports, you can also turn them off. I think, yeah, you see them on the top left. If the light is active, it doesn't work, but if the light is inactive, you can see if I press this button, you can scroll down, then you see it. If you press this button, display light guides, you can turn it off. You can also turn off cameras, for example, if they distract you in the viewport, and then it may be easier. I think I would leave it on for now, but it's good thing to do if you are distracted by all the elements in our image. What we want to do now is we want to simply increase the intensity, and I want to explain. We have an intensity and exposure. The intensity is linear value and the exposure is an exponential value. So if we increase the exposure, we only have to increase it a small bit to get a big difference, especially like if we have 10, or especially like, I want to show it to you. If we have a 12, it's quite bright already. And let's say we have 13, or let's say we have 15, it's super bright because it's an exponential increase in intensity, whereas intensity you have to increase drastically to get a result. Now we want to bring it down, let's say to 11, it's too dark, 12. Let's move it with our middle mouse button. Yeah, it's quite intense in this area. I think it's quite too bright. I think it's a bit too intense there. Let's bring it down a bit, because we don't want to be too bright there. Yeah, let's keep this that way. We want to go through all our lights because we added the texture. We can also add it in the beginning. This is maybe a better idea because then you don't have a darker light. Now we see I also increased the exposure of our second light, and with the third light we also want to increase the exposure, let's say to 11, and see what happens. Nothing happens. Turn it off. Aha, this is the light from behind. And exposure of 11. You can even bring it down a bit, let's say for 8, 9, because it's only the rim light, I think, in the bottom parts. But now we made our lighting, and what I also want to do in our lights, and every time nearly in some variation, is I want to add variation. This is what I want to do. I want to add variation in color. So I want to go through our lights and I want to change the color only a slightly bit. You can see if we increase the color, we can make it really strong. I think it's far too strong in this case, but I want to have different colors and different lights and want to increase it only a small bit. I think this time we can go with this. This is the light from this area, for example. Here we can you can see if I make it strong, it's super strong. We don't want this. We only want to have it in the way that we nearly don't see it. If we bring it a bit further to green and think it's more fresh, this is nice. If we bring it up, it's too much. We want to have it only a slightly bit. So having it only a slightly bit, I think it doesn't update. Let's go to Vulkan viewport and back to Karma again, and I have the feeling that it now everything collapses and we crash, but we can simply open it again. I clicked on autosave and let's
Good job.
let's see. We saved it 1 minute ago, so this is very good, because then I will close this. We need a minute to reopen it, but I think you can also already type some questions, because the next thing we do after we add some variation in color is we have time for questions. Now we are back in lights and we need some time to reopen Houdini, and we
No
are
problem.
back in a minute, but I think everybody can relax for a minute and then
Any
may
questions,
open everything.
anybody? I think we're good, actually. You're explaining everything really clear.
Thanks.
Yeah, I think we're good.
Thanks. In the end, it's always it's about seeing how the light behaves. And if you move the light, especially with the null, if you move it around, you can really see that it's when we get a mixture of shadows and light, which is
Looks like we do have a quick question here. Is
Yeah.
there any difference between intensity and exposure on the light setting, or are they arbitrary? They're not arbitrary. I will let Justice explain.
Yes, so the light here has the intensity and the exposure, and intensity is linear. So let's say I increase the intensity of, let's turn it off for a moment that we can see what light it is. This light, you can see the main light here, for example. If we increase the intensity by 20, it's only a bit more intense because it's linear. And if we increase the exposure by 20, it's super bright because it's exponential. And that is the difference. Exposure has an strong effect. If you change it, you can change your light extremely fast. You don't have to go up so high to change really your light. You increase your brightness a lot. And intensity is like linear, and you have to, if you want to double it, I think, in fact, if you want to double the intensity, you have to double it, so 1022. And if you want to double the intensity in the exposure value, you have to go through 13. So I think every time you add one number, I think it gets doubled, as far as I know. So that's the difference. Linear versus exponential. So now we are back, and we are still in Karma, and we changed the view to aces. And if there are no further questions, then I would simply add some color to our lights. Here we were. So we can simply, you can see, let's add some red in there. I added a bit more obvious for now because I want to explain it. We want to change different colors. You see it's super colorful now. It's too colorful. And we will take it back in a minute. But I want to explain it for now. I really like to have different, we can also try blue. Blue, I think I like blue in here because we have only a small highlight in here. This light, I can turn it off. This light now has a blue tint. If it's bigger, it's far too much. But we want to keep it that way that nobody can see it, nearly. But they see it because they feel it. And we can bring down our intensity with the other lights as well. So this is something I always want to do. I always want to bring in some color variation to our lights because this is a nice way to have a richer color palette and only a slight way. So this is what we want to do now. And if you don't have further questions, then I would simply continue with lighting and work on our lights.
Yeah,
continue
go
with
for
working
it.
on our light.
Continue.
What we now want to do is we want to add a dome light because dome lights give I like to use them to bring up the shadows a bit more because I think especially here it can be a bit more bright. Otherwise it gets too dark. You have to be very careful, especially if you want to keep some shadows, because having dome lights in default brightness could wash out your shadows quite quickly, but we will look on this. So we want to add a dome light, and I want to show you something here. Now you get a dome light without a texture. We want to add a texture in here. And of course, you can select a texture from everywhere. But I like to use a plugin. And it's a paid plugin. I only want to show it to you because it's super useful. And you don't have to use it. You also don't need it for the course, but it's used quite commonly in motion design. And I want to simply show it to you. It's the OD tools, the OD asset library in this case. Sadly, Houdini doesn't have an asset library, and I use the asset library by OD tools by Oliver Hotz, and I think it costs $100. It has lots of more functionality, but I simply plug in my Grayscale Gorilla textures and, for example, HDRIs, and then I can simply drag it over. For example, I can select the skies and the different types. So it's very convenient. That's simply something I really, it really gives me more time for design and less time for selecting and choosing textures and something. So I can simply drag it over And now we have our dome light in here with the new texture, and now it gets recreated. I also regenerated. I also want to make you aware that I want to talk about that I use the sky because I think sky could have a nice color palette and nice combination for our setup, a nice addition. And you could also use other sources. In this case, I use Grayscale Gorilla. You could also use, for example, Poly Heaven is a nice source. I could also add it. You can add like nodes to your Houdini files with Shift P. You have a node where you can add text to the header. Polyhaven, and you could also have Shift O. Shift O is for the header node. Header attachment or header sticky note, and the sticky notes, the yellow one where you can put text in is with Shift P, I think. Shift O and Shift P. So Polyhaven, simply Google this, and then you have many free textures. Here you also have lots of skies and nice HDRIs. In this case, I use Grayscale Gorilla, but you don't have to. You really don't have to. So that's something I simply use because I have it. And I want to now rotate our dome light because we still want to look how everything looks if we rotate it. Dome light. Oh, this has nice fall off on our shape, doesn't it? I like the shadows in here because they really emphasize the shape, but also the light on the other parts. I think this shadow is a bit strange. It irritates, it distracts. Let's see whether it goes away or whether it's on the texture. Yeah, it's the sun of our HDRI, which like gives a shadow through the other shapes, I think, with this shadow here. But we want to simply move it further. We want to try out different things. I like this because this rotation, this one, has a nice combination of shadow areas and light areas, and we want to have a mixture of shadows, of lights, and the main goal is always to focus on or to emphasize our main shape. We can also click on our snapshot again and create a snapshot again, and then we can look on our snapshot in a smaller size. We have to bring back aces here again. With this button, you get the color bar. And we zoom out and we see, I think this is quite dark compared to the other parts, but I think for the course it's okay because we don't have so much time to change everything. We could also have a spot, for example, in some areas, not everywhere, to have it still some shadows and the mixture of shadows and lights. There is a spot in there. I would try this as next, I think, but in the course we don't have time. That's why we simply choose this. And we could also, of course, try out different rotations. It's definitely recommended, but in sake of time, we want to keep the setup as is for now. And what we need is we need a background. So how do we add a background in Solaris? We can add a background quite simply with adding a grid in SOPs, and we can add a grid or add any SOPs with a SOP create. With a SOP create, you can add SOPs inside of Solaris. So we want to dive in our SOP create and want to add a grid. We want to add some UV. So take UV project because it's good for a grid. And then we can also give it some normals, super basic SOP stuff, and we want to give it an output because then we are not dependent on the view flag. Otherwise, we get the view flag as an output, but we want to always output the last node, which in this case is the output, which always outputs the output node. So now we have our SOP create, and we can make it visible to see our grid. We can see it here. Let's also look at it and See it in all beauty. And now we can give it a material. And I want to show you a new update, a new feature in Houdini 20.5, which is the quick material, the quick surface material, and the quick cloud material. We want to take the quick surface material. It's super cool because you don't have to have the material library set up as we did in the first session. You can simply add a quick surface material in here, and let's try to change some values. Let's bring down the color, and nothing happens. We could think that we now have the material applied, but we don't have it here already. We have to assign it first. So assigning workflow is the same, like with the material library. We attach an assign material node, and then we simply, we want to organize our scene graph, because here we have been unorganized. We have our subcreate, we didn't rename it, and if we go to the dome light, you can see we have our other objects in our scene, and you can see all the geo I put into a geo folder, and we want to do this in our subcreate as well. So let's, before we add it to the assign material, let's go to the subcreate and move our subcreate into a geo folder. And you can do this by having a import path prefix, which could be geo. And then $OS, you know this already. This is the name of the node. We can also rename it background. And then we have BG in our geo folder. And then we can also rename our material to have a nice proper name, because you see the name is from the node here. So let's call it MUD-BG. And we can simply assign our material now, because now everything is organized. We have a geo folder for our geo and materials name. And let's drag in our materials in the materials path in our assign materials node. Drag in the geo in our primitive input. And here we are. Woohoo, we changed the color, if you can remember. And we see the difference. So it's applied. Our material now works, which is nice. It's always nice if something works. So here we have everything, and I want to show you something about the quick material. You have the ability to add Copernicus in here directly in the maps, in the textures, and you have to like make it editable with this button and then go set or create, and you can simply press this icon, create cop texture for this map. Click it, and we see we have a cop net in here, which is nice because we have everything prepared. We had a base color null, a checkerboard, a default CopNet node, and then we can dive out and we see everything is connected and applied, which is super cool. And we could also apply other CopNets. So we, for example, can go to the specular and we can add a roughness map with the CopNet, simply make it editable with this icon, and then we can click on this cop icon here, and we now, you can also see it here, we have some roughness map in here. You can see the difference in between roughness, and we can dive into our CopNet, and we see we have a second null, a specular roughness null, where we can plug in everything. We can generate everything with our nice texture Copernicus context, and we can simply use this to quickly assign CopNets in our quick material. And what you also can do, it's quite nice. You can also go to here, it is add maps. You can also change the projection type between UV. Do you remember we gave it a UV? Or if it's complex to give it a UV, let's say in simulation data, it's sometimes hard. Let's say with liquids, then you want to have a tree-planar projection type. You can see the difference already. So this generates projection without UV. So that way you simply have also different projection types and quite a lot of control in our quick material. So now we have it. We want to undo our Copernicus map because we don't need it for the background, because you remember we want to do a background and we want to delete our Copernicus net again and want to merge this with our main stream because we don't see our shape. And the reason is that we are in another stream. So we want to merge both streams and then we see both together. So we merge these here, make it visible with R, and then we see our shape, we see our background, which is not in position yet, but we get there. I also want to mention something. You can also make your grid black, for example, and it's specular. You can also make your grid black, for example, and then you can use this to block light. This gives you even more control to, let's say, to add shadows if you don't, if it's not possible to add shadows with the spotlight or the barn doors or different types, then you could use grids to simply block light and to have shadow through geometry, but it renders longer, so it's not recommended if not needed. But there are cases where you don't get the results in different ways without adding a grid to block out different parts of the light to add more shadow, because remember, shadows are nice and we want shadows. So now we have a white color. Let's in fact choose a greenish color. Let's bring it down a bit and want to have an orange, yellow, green. And we could also take time to really find the best color. We don't have time now, so we simply take one. We take this color for now, and we want to move this grid into position. And what we want to do for this is we want to at first look through our camera and see the grid is not in position at all. Of course, the background is not in position at all, but we zoom out and then we see how our camera is located, how our background should be located. And to move our background, our grid, we can simply add a transform. Oh, here it is. We can wire this in before our material, let's say, and we want always, if we use transform in Solaris, we at first have to select the object which we want to transform. So we go to the Solaris scene graph path, scene graph hierarchy in here, and then we can drag in our BG and drag it into our primitives. And now we can move our background. And we can make it bring it back, and that way we don't have it intersecting with our geo, which is nice. And we want to bring it back quite a lot because we don't want to have it affected as much by the lights. We want to have a specific light for the background. And you can remember it needed to be turned down a bit in this direction because the camera is like a bit, I think it was also somehow this rotation where the camera looked at, and now we want to make it much bigger because probably it's not in our camera frame. Let's scale it up by 10, super big. We can look through our cam and we still don't see it yet. So we want to bring it up again and simply move it into our frame of the camera. So let's rotate it furtherly. I think this was needed. When we check our camera, it still gets quite a lot of different light, which I don't want. I want to really move it back. Let's see why it is not possible. I want to really move the grid back out of the light. And that way we have full control with another light over the background. We can see here we have still some areas where the grid is not in the whole frame, so it's simply fiddling around a bit until the background sits in position. Let's check our camera again, and here we have it. No. On the left, everything is missing. So scaling up even furtherly, 20. Let's see. Probably we could make it a bit better. It's still missing in here, but we can simply It's also quite far away, so maybe that's why. But I don't know why we have to make it that big. But if we have to, then we do. So here we have it, and now we have our nice background, and it's in position. We want to have another light to get some sort of a gradient to our background, to have some light and some. I think having a brighter background could also help the scene to bring it up the color, because at the moment it's quite dark, also with the shadows in the foreground. We want to have it a bit brighter, because I think it has better mood. So we want to simply dive out the camera again and go to our background. And what we want to do is we now want to find a camera angle, a viewport angle, where we could say that the light should like, if we now add a light, let's now add an area light from our current position with clicking an area light here up there on the top with control, and now we have it from our current position. And that way we simply like have somehow the right position already with our viewport. We can look through the cam and we don't see as much difference. Probably we have to definitely have to move our light a bit furtherly, so we can go with our second how's it called, network view. With our second network view, we have to go up to the stage and we have to look through our lights. You remember the typical subway. I'd like to always stay in Vulkan or stay in the viewport. Don't render Karma 2 times, because it's unnecessary, and we can see our render image on the left. We can also undo the lights, like to uncheck our light displays, because I think it's quite distracting in this case. You can also press escape to to turn off the lighting tools, and then we get a better image. Let's make it small for now, because small images are better to evaluate, especially concerning image composition and light. Now we want to move our background light. I think we have to make it brighter a lot. Let's take exposure of 15, and we really like, it's not nice at the moment because the angle is far too straight. I want to have an angle which is from the side. That way we get a nice gradient. What we also can do, we learned about spotlight. We could use this, but this has a very, very sharp fall-offs. What's also nice, is quite similar to the spotlight. It's like the exact same thing, but with a very, very soft fall-off is the focus. We have to bring it up a lot, I think, to get something like a soft fall-off from the spotlight, and it's not in the whole frame. So here I can see it better, which is like a focus, without focus. With focus, without focus. So we want to rotate it a bit, because we want to have like a diagonal, maybe this direction. This is more interesting. So simply move it a bit and try out different directions, or having it from above could also be nice. Let's simply, I think we want to have a gradient which is quite, which goes that way, to go from the side. Increase the intensity again with like 18, make it a lot more bright. And I also like that we have brighter and darker areas in the background, which gives us more contrast as well. I think having it from the other side could also be nice, because we have the, oh, now I messed it up. Because then we have lights from on the left shape, on the left background, but we can do, like, we have to work for this anyway for quite a long time. And here is also only a quick demonstration, so we don't want to spend that much time anymore on our light, because otherwise it gets boring, I think. So moving it a bit now with our right viewport, and let's keep this maybe, or can we make it a bit better? If we get close to the grid, then we increase the gradient a bit better. Let's keep it that way. Increase the brightness to 19, Yup, that's good. That's for now, for the amount of time we have, it's good. And this is our image. I want to show you some more, like one more image, one more technique with Copernicus, which you could use in lighting. So let's make our image big again, because then it's more immersive for you. Our nice image. We won't change anything on the image anymore. So this will be our result. Now we want to look into how you can add gobo to a light with Copernicus. And we want to look into render settings, and then we are done for today. So not too long anymore. We are also over time again. So anyways, that then simply unlock our camera from our viewport. Then we can change our viewport without moving the camera, and you can see it's quite untypical to have that big background, but I think it's necessary because it's that far away and doesn't matter for us, in fact. So we want to add another light, another area light, to add a gobo to it. Click on it with control, then we have it created from our current perspective. By the way, also, if you are distracted by the HDRI in the background, you could simply go with the mouse over the viewport and press D and go to the background tab and uncheck display environment lights as backgrounds, because they don't get rendered by default as well, I think. Then it's black. I think in this case it's black anyways in the background, but typically you want, I want to turn this off because then I don't get distracted. And now we have a new light, this area light, and we can see without the lights, we don't look through it anymore. Now I messed up some things, but I want to turn it off, turn it on. So simply a light from our direction. And what we want to do now is we want to add a gobo to this light. What is a gobo at first? A gobo is used, for example, if you want to have a light from a window which has the window shape and some parts which have shadows. So it's like it's a texture map for light as well, but it can have like you can add some variation to the light. You can add some different textures and shoot the texture with the light into your image. So it's quite useful, especially if you have like windows or something which you want to mimic. And what we want to have is we want to create a light filter, because this is what gobos are. They are light filters, and we can do this with the light filter library. We have to create this in front of our light or before this and dive in, create a gobo there, gobo, and here we can create a texture, which is nice. But at first we want to connect our light filter with our light. So we can now go to this mouse icon, to this cursor icon, and can select our light filters. Here they are, here's our gobo, and we can simply press apply and okay, and here it is. It's dark again because we don't have a texture yet. And what we want to do now is we want to create a texture with Copernicus. And we can simply create a texture. Let's do it on the second network view. And we want to go to the stage again and want to create a copnet. A copnet, not a copnet, but a copnet. Here it is. No, it's not popping up. Here, copnet. And we simply have it here and dive in. And you remember we have the composite view to look on our copnet results. We want to have a simple ramp. In fact, we want to have two ramps, but we begin with one. And we want to center our image. We want to frame our image with Shift-G. Shift-G frames our image. If it's far away, we can press Shift-G with the mouse over the composite view, and then it's centered. Now we have our ramp, and we can simply change it to constant because we want to have really strong contrasts in our ramp, and we want to have a window. So we can simply draw a window in here. Let's see how we can achieve this. If we have, it doesn't look good yet, but we have to improve. In fact, it looks a bit like a prism, but we can have something like a window. And let's bring, like, we don't have to perfectionize it, but you can get the concept. It's the vertical lines of a window. And we can simply build it up with ramps in Copernicus. So let's say we have these both at the same size. We want to bring this over a bit. So we don't want to take more time for this. Then we want to copy our first ramp. We want to have two because we want to have vertical and horizontal lines, and we change simply to vertical to have horizontal lines. Doesn't make sense, but we then combine these. You remember last time, in the last session, we used the maximum a lot. In this case, we want to use the minimum because if we combine these both, the minimum only uses, we can look at this, a window, something like a window. The minimum uses only the background or the foreground at the time per pixel, and it only takes the value which is smaller. So if, for example, here the horizontal line is dark, then it gets added, and if here the vertical line is dark, then this gets added. So the minimum simply is a good way to combine these both shapes because we have two dark stripes which we want to combine. Now we want to also add a text, add a noise, because we can animate the noise as well, and this is super cool with our gobo. And we make it visible. We have a fractal noise. Let's make it a bit bigger. Let's say 0.3, and increase it in contrast because then we have it have better, like stronger gobo, I think. So we want to have a remap to increase contrasts because here we have a nice ramp to change contrast. We can take the contrast, let's say, to this level and combine these both. And how we do this is we want to have these only in the white parts, and you can do this with simply adding a multiply again, because multiply only gets multiplied with the white pixels. And here we have it. We can also animate it. I also mentioned it already. We want to animate our noise by simply checking 3D noise. And if we open this, we see animate is also checked. So if we scrub through our timeline, it's animated. It could be a window with some nice clouds, for example, outside. So we want to add a null because we always want to add a null and call it out and copy it. You can see copy at the bottom, and I want to put this into our texture map. We put it in here with the OP column and paste our path, and we see we have our gobo. We can see it here. We can also move it if we look through our light, and then we can move it around. And that would be a way to have a scene where you can have like a really nice window light. If we dive out of the light, we can check it out how it looks like. So if you have objects on the bottom, for example, here, it could be nice to have a evening window. But for our scene, let's check how it looks like in fact. We get some variation, but I think it distracts. I think I don't like it because it distracts. That is the reason we want to turn it off. And now we simply only have to render it and to set up our render settings. The first thing I want to talk about is you have the render settings here, which also added them already last session with the karma. If you don't have render settings already, you can simply add the karma. I can also add it for now. And then you get these both nodes, karma render settings and USB render up. The first thing you want to do is to check whether the camera is the right camera in here. And you see, if I have the karma render settings active, you see the resolution, if we look through the camera, is the resolution which we set up here, which makes sense. But if we have a node selected or visible before the karma render settings, then we get our screen resolution. So at the moment it's 1731 pixel and so on in width. And if we make the viewport small, it's really small image. So if you, let's say, want to have a screen resolution then I would make the nodes before Karma render settings visible. And if you want to have the Karma render set, if you want to have the specific resolution in the viewport, then I would make the Karma render settings visible. Now you could also say maybe Karma is slow, and then you can simply decrease the resolution to make it super fast. It's also pixely or like worse in quality, but you can make it slow, decrease the resolution and make the Karma render settings active to increase your speed of Karma. In fact, Karma had a really strong speed improvement with Houdini 20.5. So they have, I think they doubled the speed, so it's super fast now. They say it's even better on the fourth generation of RTX cards. So they officially say it's 4 times the speed on RTX 40 series. But I want to have a resolution of full HD, so I want to have 1920 by 1080, which is nice. And what we then want to explore is a new feature in Houdini 20.5, which is the adaptive sampling. We can stay in our Karma render settings and go to the advanced tab to sampling. And here we have now variants, which is the adaptive sampling, which is super nice because we get quite speed improvements if we activate it. At the moment, it's -1, which is something like infinity. So we want to have minimum samples. We want to define it. We want to increase it. And you can say like our main path trace samples are the maximum samples and our minimum samples are the minimum samples, of course. So what you want to typically have, typically is like you want to at least have path traced samples like the maximum samples of 512 with Karma XPU. You remember we also set up XPU in here. So that is important to use XPU if you want to use XPU and not CPU only. This is done already, but here we have our maximum samples. Our minimum samples, you should have them below your maximum samples, of course. So let's, for example, have them at 256. Yes. And then I don't want to get super into details here because we don't have that much time, and it will be more about Copernicus and design this session, this class. But you can also I also want to explain only quickly the variance threshold, which defines it's is like a noise threshold, and if you decrease the variance threshold, you get more pixels towards the maximum samples, and if you increase it, you get more pixels towards the minimum samples. We want to leave it as is because it's quite good value for a mixture of speed and quality. So we have our adaptive sampling set up, and what we also want to do is we want to denoise for now because we want to I think we are quicker. We don't have to bring up our samples that much then for now, and we can simply go to the image output tab to filters and then go to NVIDIA Optics Denoiser, and we want to also display our renders in the mplay, and we can do this by selecting the USD render op, going to Husk and then to monitor, and then check mplay monitor, and that way the renders get displayed in mplay. And then we set up everything. We can of course change our render frame rate, our frame range, and here we have the whole frame range selected and can simply press render to disk. We have the other, like on the other screen, I have the render, how it begins, And I want to also show you mPlay opens up, and we want to change mPlay to aces again to see our exact same results. And we nearly made it. I only have a homework for you. So we learned about image composition, that you have to take a close look on light, how it behaves when you move it, and then to shape the objects in a good way, a mixture of light areas and shadow areas. Then you have to also, you have learned about image composition, that you should at first see your main shapes, especially by zooming out, and that you should also use these main shapes, for example, in circular shapes or in S and C curves. And this is something, as a homework, which I want to give you, that you can revisit old scenes from you and apply. Let's say you redo camera and lighting to really apply what you learn now, to learn it, really. So because applying this is the best way to learn it. You can also, of course, applying on your at work or at working projects. But this is my homework, to really go to old scenes and apply this, and you can see our render makes improvements. Now you've got the ability to ask questions, and we made it through our second session.
Really, by the way, the result is gorgeous. The lighting is so good. I love the displacement you have. Really fantastic work. It's such a great class. Are there any last questions, you guys? So we all want to see you practice, 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 as Christopher say.
Hey, Deb, can I
Yeah.
have one thing real quick?
Yeah.
I just really want to tell him thank you, thank you, thank you. That was a fantastic class.
Yay.
Yeah. I got so much out of it. And
Thank
I've been making
you.
notes along the way. So yes,
Justice, I hope you're feeling the love here.
yes.
Thanks so much. I'm really glad that you could learn something. You said you used like Houdini for so long already, and
Yeah.
it's so
Yeah.
nice to hear. Thanks so much.
Yes, thank you. Appreciate it.
Okay. Thank you, Christopher, and thank you, Justice. I think we're good. Yeah, everyone seems to have gotten something out of it and enjoying it. So we look forward to seeing what everyone comes up with, and we'll see you all next week.
Thanks for joining. Thanks for staying until the end.
Thank you so much. Okay, bye everybody.
Have a nice day. Thanks.